Yes, no?
Yes.
Yes.
Great, thank you. Thank you very much, Cindy and Alex, for inviting me for today's talk, this evening's talk. This is a great honor, and I've got a tall order here. This is exciting. I've got Aaron Jackson, Jeff Jolly, John Schaefer, Rod French, and my friend from Japan, Hiro Arakawa. And these guys all know a lot about lamprey, and so I'm just humbled that you guys would tune in to watch this, and thank you. This talk is going to be, for a food metaphor, a bit of a pancake talk. Cindy mentioned going into depth. I'm actually going to be going quite wide and a bit shallow. So I hope that this isn't boring for folks like Aaron and the other folks I mentioned, but because we've got a varied audience, I'm going to be covering a lot of topics. So thanks again for tuning in. I've been working on lampreys since about 2006. And make sure this thing moves forward. Okay. And I understand this thing's being recorded, so I did want to have just a brief disclaimer here that if you're viewing this presentation a few years from the year 2020, please feel free to contact me at ODFW for the most up-to-date information. So I've always been fascinated in fish ever since I was a little kid. That's me on the left, and that's me on the right more recently. The hair is less on the head, but more on the face. But I'm very excited and lucky to work on what I work on, and lamprey is a passion. So for some reason, oh, there we go. Okay. Lampreys, 40 species worldwide. Primitive fish, eel-like, no jaws, and they've been around for millennia, almost 400 million years. And this is a graphic that comes from Jeremy Five Crows from the Columbia River Intertribal Fish Commission. And it's an awesome graphic because it really puts into perspective how old lampreys are as a taxa compared to dinosaurs. And that's something we can really use to capture the imagination of people that may not know about lampreys. The other thing that's really interesting is they've changed very little over this time period. And they've survived through 4 global mass extinctions, which really puts into perspective more recently in the last 100 or so years with decreasing numbers. It's quite a sobering thought to think that these animals have lived for so long and now are dwindling in numbers. A lot of people don't realize that Oregon and the Pacific Northwest are a hotspot for lamprey diversity. In Oregon alone, we have 10 species. That's about a quarter of the species worldwide. Most of these live in the Klamath Basin, and a few more live throughout the state. And lamprey are incredible ecosystem integrators. Here's but one example of many where predators are shown consuming a Pacific lamprey, a sea lion and a bald eagle. They also perform a number of really important ecosystem functions. And they are also very important to Native American tribes. And this cannot be undersold or underestimated. The tribes have been leaders in managing lamprey, researching them, and sounding the alarm about their dwindling numbers. And the numbers of lamprey used to be abundant almost 100 years ago. But more recently, they've decreased significantly. And that's been linked to many different limiting factors and threats, of which a few are shown here, including artificial obstructions, flow management, habitat degradation, dewatering, those are larval lamprey, and low water quality. Therefore, the tribes, the Columbia River Intertribal Fish Commission, were the first to develop a tribal restoration plan for Pacific lamprey in 2011. More recently, the Pacific Lamprey Conservation Initiative is kicked off in 2012 with 30-some signatories, including my agency, and it's administered by the U.S. Fish and Wildlife Service. Even more recently, I led a team that created the conservation plan for lampreys in Oregon, which includes Pacific lamprey and also 3 other species. So that's a story arc. That is what I'm going to cover today. And now I'm going to slow down and go through some of that same information and provide some more details. So species, there's several. Status of those assessed in Oregon state. The state of Oregon has determined they're sensitive. Biology is complex. And the management has occurred at different levels, led by the tribes, and then more recently by the federal agencies and now state agencies. And it's great to see watershed councils really getting interested in this. So here's a distribution map of Pacific Lamprey in Oregon. The blue is a contemporary distribution. Red is a historical distribution. And notice the red is linked to where river impoundments occur. Compare that with the other anadromous lamprey, Western River lamprey, which is smaller and more concentrated in nearshore ocean in the estuaries. We don't know as much about them, but what we do know suggests that their distribution is less widespread than Pacific lamprey and is roughly below Bonneville Dam to the mouth of the Columbia and then down the coast to Yaquina Bay. There are a few caveats and other addendums to that distribution, but for our purposes today, this is generally what their distribution is. And now, here's a third lamprey, Western Brook lamprey, a freshwater resident. Smaller than the other two, they don't go to the ocean. Their distribution is intermediate to that of Western River lamprey and Pacific lamprey. Finally, the other lamprey I want to briefly mention is Pacific Brook lamprey. Very similar to Western Brook lamprey, only from what we know, they are distributed in the Willamette Basin in Lower Columbia. So here are those lampreys shown by relative body size. And again, the top two are the anadromous ones that go to the ocean to feed on fishes before migrating back into freshwater, spawning and dying. The bottom two, when they transform from larvae, they go right into adults that don't feed, but simply spawn and die, all in freshwater. And again, our assessment statewide for these species is that they are all sensitive. They are on our sensitive species list, and as a consequence, they are all Oregon Conservation Strategy species. One more lamprey, a fifth lamprey that's been assessed, one of our first fish conservation plans in 2005, is a Miller Lake lamprey, the world's smallest landlocked lamprey that occurs in Miller Lake south of Sun River. Its status is also sensitive. Now that I've mentioned 5 out of the 10 species, I'm now going to dig deep into Pacific lamprey alone. That's the species of our interest today. It's the biggest lamprey in Oregon. It's also the most widely spread lamprey in Oregon and rivals the distribution of other lampreys in the world. So all around the North Pacific Ocean and drainages thereof is where Pacific lamprey exists, including Russia, Japan, Alaska, Bering Strait. So I already mentioned the importance of lamprey to tribes, and folks like John and Aaron can speak more clearly to that than I can. But it bears repeating, Elmer Crow, one of the kindest people I've had the privilege to meet, has indicated the lamprey is our elder. Without him, the circle of life is broken. I've often heard Elmer and Dave Close and others say as well that if we want to recover salmon, we need to recover lamprey. Here's another one of my friends, Doc Slider from the Confederated Tribes of the Kuzla, Umpqua, and Siuslaw, playing a flute before we conducted our radio taking research on lamprey. And now here are the life stages, larvae to adult. The larvae can be as small as an eyelash, really, really small. As they grow over 3 to 10 years, they can go up to about 4 inches before they get the right cues physiologically and environmentally to transform into juveniles that have eyes and teeth in their mouths. Prior to then, when they're larvae, they don't have teeth, they don't have eyes, they just filter feed on algae. Now these juveniles, when they transform, are migrating out of freshwater into the ocean where they'll feed on fish and even whales before they get to adult size and migrate back to spawn and then die, providing marine-derived nutrients. Really, really cool. And they spawn in the spring. So here's a life cycle depicting what I just described in a slightly different way. Parasitic juveniles migrate back to spawn and die. Larvae are in the bottom of rivers. They're kind of the earthworms in the river. They aerate the bottoms. And there's been research on that shows that has a benefit to river ecosystems. Then they transform, go back out to the ocean. So now I want to slow down and take you through a picture example of what their life cycle is like. As a juvenile in the ocean, feeding using their mouth. Their scientific name is Entosphenus tridentatus. The tridentatus part is from the 3 teeth here. These are on juveniles and adults. And you can see the circumoral teeth. There's 2, 3, 3, 2. This is a tongue piston that comes out, can rasp a hole into the fish, and then they can feed on blood and tissue. There's no evidence that lamprey, Pacific lamprey, have decimated host stocks in the ocean, unlike the invasive sea lamprey in the Great Lakes. Rather, they have evolved with their prey base. And that's one of the first things I like to tell people who get really weirded out by them. And every now and then we get those questions. Here's a picture from my colleague, Dr. Lori Whitecamp, showing lamprey captured in the ocean. The bottom ones show ones that are probably within the first year of growth, where they grow massively. And the ones towards the top are more adult size, probably on the way to migrating back. Here's a picture of a Pacific lamprey migrating during the daytime from the ocean into freshwater. And this is confused lamprey biologists when they see this picture, because most of what we know is that these animals are nocturnal, that they're very active at night. So it's interesting to see during the daytime migrating into freshwater. So now I want to continue to take a journey on into freshwater with you through the rest of the life cycle. And by the way, Pacific lamprey can migrate, historical knowledge is all the way up to British Columbia and well into Idaho before river impoundment. Really incredible. So when they migrate back, they encounter some natural barriers, like here, Willamette Falls, where they're subject to a tribal harvest. And here's one of my pictures. You can see the difference in body size on one capture date. And there is actually life history diversity in Pacific lamprey. I don't know if you guys are familiar with summer and winter steelhead, but this is a little bit analogous to this, that by a number of physiological parameters and more recently by genetic markers, we and others have identified 2 life histories. A stream maturing one that comes back, spends at least 1 year, sometimes 2 or more, not feeding in freshwater before they spawn and die. Whereas there is also an ocean maturing life history that we've found in the Clemens that we estimate can spawn within the same year that they come back. And so it's really exciting time, because each year we're learning more and more about these animals. So now I want to take you on a tour. We had the good fortune of having a collaborative work group with the Confederated Tribes of the Grand Ronde, Kramer Fish Sciences, Oregon State University when I was there, and funded by CRITFIC, Columbia River Intertribal Fish Commission, to tag almost 500 Pacific lamprey and track their movements. And that's what we did. And so what we found, not too surprisingly, is in the Willamette. So the rest are pictures from the Willamette Basin, that in the lower part of the river, most of the fish are found in the main stem, not associated with structure, unless it's structure that we couldn't see from the boat. The more you got upstream, the more rock revetments we encountered, which are put in place to keep the river from meandering. And in those rock revetments, we found an awful lot of lamprey. Probably a good place to hide if you want to evade predation by a white sturgeon. Also found a number associated with boulders, logs, root wads, and sometimes even bridge pillars. Now consider the channelization of the Willamette, main stem Willamette, over 100 years, 150 years. So you have river impoundment during the 1900s, you have snag removal, so steamboats can come up, And as a result of this stuff and riprap rock revetments on the shoreline, the river becomes less braided, less complex, more channelized, more straightened. Now consider here 1932 and 1995. We'll revisit these here shortly. Now looking at total lamprey harvest, remember they used to be really abundant, early 1900s. And here is the harvest. So 1932, very roughly, approximately 500,000 lamprey were harvested or available. And then 1995, a fraction, and then more recently, even a fraction of that. So really a drop off during the same time. And so, well, you need to be careful here and say correlation is not causation. When I see all this, it makes me hypothesize that the simplification of the main stem willamette, in addition to the other limiting factors I mentioned earlier, probably had something to play in having a lower number of lamprey harvested over time. Pretty sobering. Now I mentioned the larvae are like earthworms of the river. So they're migrating on, they're feeding on algae, bacteria, detritus, microorganisms, and they're emitting pheromones. And those pheromones are what attract the adults back to fresh water. And so there's a connection there. And some people have used this to say, okay, well, if there weren't lamprey, say above Powerdale Dam, how did they recolonize that if there weren't pheromones? Well, I don't think it's that simple that you have to have pheromones, but I think it can be helpful. I think lamprey, if we give them a chance, in some situations are resilient enough to recolonize whether pheromones exist or not. Here's a picture of where we tracked a lamprey to in the Marys River in the Willamette Basin. At the end of a pool tailout in cobble, and they make a pot-shaped nest where they pull the rocks out. These are some Pacific lamprey that we had taken to the lab and studied their spawning. And I'm showing you here to show you that these things really shrink. They can shrink up to 30% in their body size because they don't have bony skeletons. And as a result, their length goes down and all that energy gets fueled into the migration and production of oocytes and spermatozoa. So these are males at the top. This is a female. That's all eggs. And there is so fecund, they can produce upwards of 200,000 tiny 1 millimeter eggs. Well, and so that's really interesting to note because that life strategy, really fecund, long living, die after spawning, is linked with periodic life history strategists. In the fish life history literature, what are periodic life history strategists? They're ones that live in dynamic systems that are either boom or bust. You can imagine places like the Willamette, Columbia, before impoundment, channelization, are probably quite dynamic. Here's a picture of a pair spawning in the Drift Creek on the coast. Really cool, so they can spawn undercover. And now I'd like to show you, if we've got time here, a bit of a clip of some lamprey spawning in Clatskanie River by my colleague Derek Wiley. And so bear with me while I unshare and then reshare the web link. I'm not seeing, it's interesting, I'm not seeing the share link here. Bear with me, this is the first time I've done this. Okay, I think I've got it here. Okay. Can you guys see this YouTube webpage here?
Yes.
Great, thank you. I really appreciate that. So now let's eat some popcorn and watch some of this here. Really interesting. Go. Again, filmed by Derek Wiley of Oregon Department of Fish and Wildlife. Okay, I think we'll leave it there in the interest of time. You can Google that if you want to watch more. And now I'm going to stop sharing and reshare my PowerPoint. Okay, so before I go on, you saw a smaller lamprey spawning in that video. You may or may not have caught the title at the beginning. The big lamprey or Pacific lamprey. The smaller ones are Western brook lamprey, one of the freshwater residents. The best of our knowledge, they don't interbreed with Pacific lamprey. They're opportunistically using that spawning site. Really pretty cool stuff. Okay, moving right along. Here are examples of habitat that larvae can use. Type 1, type 2, type 3. This terminology comes to us.
You have
Yeah.
to share. We don't see your presentation right now.
Sorry about that. Okay, can you see it now?
Yep.
Okay, great. So here, you didn't miss anything. Type 1, type 2, type 3. Terminology comes to us from the Great Lakes. Basically, take home here is that there's type 1 habitat, there's depositional, silty, sandy stuff. This is prime larval lamprey habitat. Although larval lamprey can also be found in these other habitats, type 1 is the primary habitat that they use. So here they are like earthworms, burrowed in the sand. And here's a picture showing how they can filter feed as really young. So these ones are probably young of year, and they're filter feeding through their mouth. Here's an example of type 1 habitat. Now consider catch per unit effort. One of the studies that I was involved in looking at backpack electrofishing wadable streams in the Willamette, our catch per unit effort, very rough proxy for abundance, found that most of the larval Pacific lamprey were in off-channel habitats. And so not too hard to imagine, once again, revisiting this complexity of the Willamette River years ago when lamprey were really abundant, according to relative harvest, probably had a lot more off-channel habitat at that time. So when we think of habitat restoration to help fishes, a lot of work has been done on coastal coho salmon. Habitat restoration of small streams because it's doable and we know coho use them. Another species, conversely, Oregon chum, uses primarily estuaries and large rivers, which aren't usually the subject of habitat restoration. To the best of our knowledge, Pacific lamprey uses all of it. And so the extent we can get work in small streams and bigger systems, the more likely we are to help Pacific lamprey. Now, I mentioned earlier ecosystem integrators. Here is a good example. Pacific lamprey, 41 documented predators. And they prey on, or I should say parasitize, 32 different species of prey. And that's pretty incredible. And really put it into perspective, Pacific lamprey are 2 to 3 times higher caloric density than the species of salmon, which when you take bones out of the picture too, probably makes them pretty easy forage and maybe even preferred forage for a lot of animals. But as I mentioned earlier, we have a number of limiting factors, passage and culverts that may be raised or don't have structure inside them. Passage that's designed for salmon in mind and not lamprey. And here's an example of a Pacific lamprey trying to pass the fish ladder at Winchester Dam before we put the ramp in there. This is from my friend Ralph Lampman. And the moral of the story here is that 90-degree angles, Pacific lamprey cannot navigate. They're burst and attach swimmers. '90-degree angles, not good. Other limiting factors and threats include dewatering, which can literally desiccate and kill thousands or millions of larval lamprey, multiple age classes. Low water quality, really warm temperatures, toxic spills. Degraded habitat, and something that really takes to degraded habitat is warmed up and simplified is a non-native smallmouth bass, which anecdotally and empirically has been shown from friends in the Coquille River and also in the Umpqua River, really can consume a lot of larval Pacific lamprey. So I mentioned the different tribal, interagency, and statewide conservation plans to address these limiting factors. And now instead of providing you a laundry list of the stuff we're doing, I'm going to provide you some picture examples. And one of the key management strategies for us at ODFW is outreach and education. We believe everything flows from that primary management strategy. So it's no longer copacetic to say we don't know enough, we can't do stuff. That's not even true. So here's one example, working with my colleagues from Columbia River Intertribal Fish Commission, Yakima Nation, U.S. Fish and Wildlife Service. We put on an ID workshop at the Dells, something we'd be happy to do again. Also worked with other instructors to put on a short course through Portland State University in Astoria. The same group of instructors and I worked on putting a short course together by invitation to River Restoration Northwest. And the Oregon Zoo, if you don't know, has a new lamprey exhibit that came out in the summer of 2019. And I like this because so many people focus on the cute and fuzzy stuff. And here, the zoo flipped that right on its head and made it funny and I think effective. The cuteness is coming. Here's another video of a strategy that many people are implementing, from tribes to feds and my agency as well. Putting up lamprey ramps, aluminum flumes that range in different angles from vertical to 45 degrees that lamprey can use burst and attach swimming to ascend. So I believe this one was taken from Bonneville Dam from colleague Dr. Mary Moser. So it's just a thin sheen of water going over top, and here's the lamprey using burst and attach swimming to inch its way up. This kind of swimming before dams allowed them to pass obstacles like Willamette Falls. Pretty incredible. Of all the 40 species worldwide, there may only be one other that's able to do this, and that's in Australia. So if you haven't seen the structures at Bonneville Dam, they are pretty impressive. They're very elaborate, and that one goes up into the forebay. Here's another example. I believe this one's from the lab, showing the same kind of behavior. And the adults also give off pheromones as well. And so that's probably one reason why they come in batches and pulses. Culvert retrofits have been performed, which is pretty much mini lamprey passage structures. And people are starting to become more aware of habitat-based simulation within culverts that are more natural, that can allow for, probably encourage more passage. And habitat restoration, that's $1 million question we keep getting, is what restoration is needed for Pacific lamprey? And I can't give you a clear answer yet because lamprey biologists don't know. We do know that there is a linkage with large woody debris, which captures sediment, creates pools, more depositional habitat, and therefore more larval lamprey. We also have a reason that a process-based restoration is effective, but more research needs to be done, like on the stage 0 restoration in the South Fork Mackenzie and on 5 Mile Bell on the coast. We've got a proposal in to look at that. Myself and other colleagues from other agencies have worked and created a best management guidelines for native lampreys during in-water work. You can Google this, it's available online. If you see this or you're interested in this or other things I've mentioned, please feel free to email me. I'm happy to share them with you. And working with district biologists and tribal partners, watershed partners, to conduct radio tagging studies to track their migration behavior in 10 Mile Lake Basin and at Leeburg Dam in the Mackenzie River to look at passage. Also looking at research for distribution to see where they are. Really lacking distribution information in areas east of the Cascades, with the exception of areas where tribes have translocated lamprey. And kind of bringing in the home stretch here, part of our plans for research are to monitor and try to predict abundance in relation to barriers and in relation to distribution, so species distribution modeling. And a lot of this can't be done with some of the people that are on the phone here, including John Schaefer there on the left. This is the 10-mile lamprey group. I'm one guy for an entire state, and so I emphasize to people to get stuff done, I need to collaborate with people, and I'm happy to do so. Here's the same group, some step partners in there, district staff, tribal staff, Kuzla-Umpqua and Siuslaw Tribe, 10-Mile Lakes Basin Partnership. Here's the group from Confederated Tribes of Grand Ronde, Eugene Water and Electric Board, U.S. Fish and Wildlife Service, and my agency. Did a dewatering study that's in press right now, should be available soon. And then some of my friends and I that were invited to Detroit for the Sea Lamprey International Symposium, where I didn't hesitate to remind them that when they told us that their outreach program for sea lamprey in the Great Lakes wasn't effective, that I told them that, in fact, I respectfully disagreed, that it was actually too effective. And so now finishing up here, to summarize, I talked about several species, 10 species, in fact, that live in Oregon, the sensitive status of the 5 that have been assessed, the fact that their biology is complex, and the fact that management research is happening on many levels, led by the tribes and federal agencies and the state. And with that, here's a few thank yous, and there's a number of people that just isn't space to include here, but thank you.
Ben, thank you so much.
You're welcome.
Gosh, you know what? We hadn't talked about this, but anybody that wants to unmute, we could try a round of applause.
That was awesome.
Very good, very good.
Yeah.
So cool. So you're welcome to use the chat box, but I would like to, Chuck and I would like to open it up for questions. So you can unmute yourself, and let's try to keep the background noise to a minimum so everybody gets a chance to hear and talk if they'd like.
I have a question. I'm wondering what the latest is on, I know there's been work done, I think, by the USGS on trying to figure out the challenge in screening larval lamprey from water withdrawals. I'm wondering what the progress has been or what the status of that research is.
Yeah, that's a good question. The most recent up-to-date information is available in that in-water work guidelines that I flashed up on a screen. There's a summary in there. Marty Litke is the one at Cook Lab, Washington, USGS, that's been involved in lamprey research. And to my knowledge, she hasn't done anything on screening recently. And I could provide you more detailed information offline. I don't have it on the tip of my brain, but I'm not aware of anything happening more recently.
Thanks.
Feel free to email me. Again, I'm very happy to provide information.
Okay. Thank you.
Yeah, that's a good question, Holly. I had a question for you, Ben. So, you know, as we mentioned early on that lamprey are returning and kind of going more and more into the Hood River Basin up all of the 3 major tributaries, and that the ODF and W cohorts are finding them in screw traps, and you know, the tribal surveys are finding them in you know, through their pit tag, let's see, not pit tag study. Is it pit tag studies? Shay, the lamprey studies that the larval studies that you're doing. And I can't remember, I guess it's just doing e-fishing for larvae. but they're clearly moving up more each year, and they stay a long time in the watershed compared to other anadromous species. They're around for a long time. And the other significant anadromous species in the hood is steelhead, who also their juvenile life history stage is around for quite a while in the basin. And I'm wondering if you think that we'll see, given that lamprey larvae can be a food source for juvenile salmonids, do you know of research, or do you think that we might see a response from lamprey, or excuse me, from juvenile steelhead in terms of an increase in the production rate of juvenile steelhead outmigrating as lamprey numbers increase in the basin?
Oh, very good question. Ecology is very complex, but I think that's a fair prediction that that you've got some synergy there. Dave Close has hypothesized in the past that larval lamprey provide a predation buffer for salmonids. So we've seen pictures of gulls whose stomachs are just crammed full of larval and juvenile lamprey. You can imagine that the extent that's happening, they're not preying on salmon or steelhead. And so that's one potential function. And the other potential function I think you implied there is that perhaps steelhead would have the larval lamprey to feed on. Is that what you're suggesting?
Yeah, that's what I was wondering about.
Okay. And so, hate to do it, but want to put my colleague Hiro Arakawa on the spot because I know he's done a predation lab study and he could address that very question. Hiro, do you feel comfortable answering that question?
Could you say the question one more again?
Yeah, I got it, Cindy. So, Hiro, can you speak to whether you studied steelhead or salmon eating larval lamprey in the laboratory?
Oh yeah, we conducted the predation study, and then we use a lot of predation species, and then like sturgeon and then common carp had a large potential to predate on the larval lamprey, and then others like a small mouse bass or northern pipe minnow did not show the predation behavior, and then also salmon also did not show the predation behavior. Yes.
Okay,
So,
thank you. So you're suggesting that the juvenile salmon, based on your study,
Yes.
would not eat larval lamprey.
Yes.
Okay. Okay, great. Thank you.
Hmm.
So Ben, to follow up on that, the ecosystem services that that Pacific Lamprey provide, like let's say in the Hood River watershed, it sounds like water quality could be one, aerating the stream bed substrate perhaps could be another, or and are there others besides that?
Yeah. Yeah, it's a really cool idea. So they're providing marine-derived nutrients. As larvae, you're right, they aerate the bottom. They're recycling nutrients when they're filter feeding as larvae. And there's been evidence in just aquarium observations that you've got a cloudy aquarium, put a lamprey in there over time, it clears it up. Also, some work that I've done with John Schaefer, Richard Litz, and Gary Vondero with radio-taking lamprey in Eel Creek, Lakeside, and the Oregon coast indicates that a huge number are predated by osprey, probably river otters, mink, you name it. So I mean, it's kind of like not even just the river itself, but also up onto the banks. You can imagine the spread of nutrients as the carcasses are dragged in there. Oh, and I forgot to mention too, when they're spawning, there's evidence that when they're creating their reds, they're creating some microhabitat complexity that's correlated with benthic macroinvertebrate diversity, which then feeds juvenile salmon. So the more we look, the more connections we're finding.
Any other questions for Ben? Let's look in the chat box. Thank you. Let's see. And then Hero had some questions. Ben, do you see those in the if you click on the chat box?
Okay, I think so. I see one. Oh, let me pop it out here. Okay, the Pacific lamprey in the picture, which migrating on river side of river mouth in the daytime, does it represent active migration in the daytime? For me, the individual seems to look for the habitat to rest. What is the suitable environment in the river mouth for migrating lamprey? Well, that's a great question. I think I would address that in layers. So first off, it hasn't been well studied in Pacific lamprey. So the quick answer is we don't know for sure. The longer answer is we know from sea lamprey in the Great Lakes that they can migrate to right off the tributary river mouths to the Great Lakes and burrow into the sand and kind of hang there until they need to do their spawning migration up inward. And so it's possible they might do that. But again, what we need is like a tagging study to really track and see where they go. Really don't know what they do. I know in the Klamath River mouth that they migrate at daytime, they migrate at nighttime. We used to collect them at night when the tides would push them up on the shore, we run and grab them. So it's really, Hero, a wide open topic, just a lot of speculation on my part because it hasn't been studied.
Okay. Yeah.
There's a comment from John Schaefer that he said that they lost a tagged lamprey today and there was a blue heron feather near the tag.
This is funny. So I was working on this talk and another talk I gave today, and I saw the email from our colleague that said feather ID, and now I know what he's talking about because I hadn't a chance to read that email. Yeah, blue herons, they've been documented definitely to consume lamprey, which is pretty crazy. You'd think that they would asphyxiate trying to get something like that down their throats, but I mean, that's pretty incredible. In fact, I think if I remember correctly, there is a document that a blue heron was found dead trying to ingest a Pacific lamprey. So definitely gluttonous, trying to consume that much energy.
Hey, any other questions? Thank you very much again, Ben. And I'm guessing.
Can't hear you, Cindy.
Oh.
There you go.
Okay. I just was saying thank you very much again, Ben. And I'm guessing that you will get some emails, probably from me, well, from me for sure, and probably from some others. So if you want to stop sharing your screen, we will cut you loose.
Great. Thank you very much, Cindy and Alex and everybody for tuning in. I really appreciate it. Good night.
Thank you.
Yeah, thank you very much, Ben. Yeah.
Hey, Cindy, a real quick question. I missed the first part. It looks like this is recording. Is this going to be viewable again later?
Yep, it will be on our website.